15.713, I'll read this to you and then we'll talk about it. So suppose S is a closed surface with area 12 pi, and that F of XYZ is a unit vector making an angle of pi over 3 with n, XYZ, the outward unit normal vector, to S at XYZ. Calculate the divergence, or the triple integral of the divergence of F, where V is a solid. So let's just, the solid enclosed by that S. So the divergence theorem states this, right, that the integral, the triple integral of that divergence is equal to the flux, right, which is the integral over S, F dot ds. Does that make sense? And so I think we mentioned this formula along the way to get there, but I can't remember for sure. But this is, right, F dot N ds as well. And so you're over this saying S. Okay, and so this is what we need. So the pieces of information that we were given were what? That, let's see, find out where I'm at. Okay, so that F is always a unit vector, right? So they don't tell you anything about anything that's going on. Right? You've got some surface here, and then you have some, no idea what I'm trying to do. Something like that. You got some surface encloses some B, right? And they tell you, or they want you to find this divergence, and they give you information about the F and the normal vector, right? And so what did they tell you? That the angle between the F and the N was always pi over 3, right? And so remember your formula, cosine of the angle between two vectors is u dot v over magnitude of u, magnitude of v, right? And so now you know the pi over 3, and so I guess with F and N in place, what's the magnitude of F? What's the magnitude of N? They were both unit vectors, right? So that's 1 in the denominator. That make sense?
Oh, so N is
So-
also a unit vector?
Yeah, I mean, that's the definition of N. Remember, it was N was R cross, or R sub U cross R sub V over its magnitude, or the negative of that.
Oh.
And so you just pick the appropriate one that's sticking out. And so then we have this formula. So F dot N is just cosine of pi over 3, which is 1/2.
Oh, yeah.
Is that okay? And so you end up just getting here the surface integral of 1/2 ds. And then, again, we have no information about the surface other than that its area is pi, or was it, what was the area? 12?
12 pi.
12 pi. And so, but that's what this does, right? This will be 1/2. If you integrate just the
Yes.
function 1 over a surface, you get the area of that surface. And so this is just 1/2
Times 12 pi.
times 12 pi. So 6 pi. Does that make sense? So that one's a little bit unusual, the way they went about asking things. Hopefully that makes sense.
How we know the magnitude of F and the magnitude of N? is
So,
one?
so the magnitude of N is always 1, because N was defined, again, to be that cross product over its magnitude, right? So it was always a unit vector. And then they told you in the directions, this was, and that capital F is a unit vector. So they told you it was like the one to start with. Does that make sense? Okay, anything else? These get a little messy. I actually did some of them ahead of time because they were so ugly. I worked them out ahead of time, which I don't normally do.
So we return the factory subscription that every time you give to us. Have 4 questions usually?
I guess I'm not sure what we're asking. All right, I think we're good with this section. What's that?